Which element has an anomalous electron configuration due to extra stability in half-filled orbitals? So anomalous electron configurations are electron configurations that deviate from normal Aufbau principles. And these occur when an element has the option of creating either half-filled or fully filled d orbitals, because as it turns out, having all the d orbitals having one electron or all the d orbitals having paired electrons actually imparts a lot of stability. What we need to memorize for this is that the elements that oftentimes exhibit these anomalous electron configurations are going to be in the following groups. And there's some extra ones, but I think for the purposes of the MCAT, these are really the good ones to remember. And so if we take chromium, for example, we'll do this, but we'll do it the way where we just fill the orbitals one by one, right? We're going to have electrons. And remember that we can use a noble gas configuration, since basically the noble gas of the previous period was argon. We'll start with that. So you're going to start with at least argon. And then remember that in period 4, you have the 4s orbital. And then also for these transition metals like chromium, you're going to then have the 3d subshell available, which has 5 orbitals. 1, 2, 3, 4, 5. And remember that when you're actually filling these orbitals, the 4s is considered lower energy than 3d, so electrons will start by going into 4s. So let's just add electrons one by one, starting from potassium. So with potassium, you would put an electron here, and then calcium, you would pair it. And then after that, you're getting into the transition metals, so you start adding electrons. So scandium here, you're going to put one right there, then titanium, then this, then you get to chromium. So for chromium, you're going to add an electron there. And normally you would think, okay, well, that's it, we can move on to manganese. But chromium, actually, this is not the true electron configuration for chromium. This is the expected electron configuration. But what chromium actually does is when you get to this point, this electron, one of the electrons from the 4s orbital will move into the 3d orbital, basically making the 3d orbital half-filled. Why does that make sense? Well, the reason, as it turns out, is that when you have a half-filled 3d orbital, okay, that is actually more stable. And part of the reason also is that, like, the half-filled 3d orbital imparts stability, and also you can achieve that half-filled orbital with chromium because you can take an electron from 4s, which is paired, and put it into that empty 3d orbital. And that also relieves some electron repulsion in the 4s subshell, right? Because you're no longer having paired electrons there. So this would be an example, a classic example of an anomalous electron configuration, where what we expect, right, if we just follow the normal principles, is that you would have this, but in reality, this electron gets moved up here. Okay, let's do the same thing and go up to copper. So we want to figure out coppers, right? Well, we got chromium, and so then the next electron you're going to put into 4s for manganese, right? Because again, the 4s is available, it's lower energy when you're filling it. And then you're going to get into iron, okay, and then we're going to keep going like cobalt, and then you have nickel. Okay, and then you of course have to put the electron in for copper, and then once again we have the situation where we can keep it this way, which is the expected configuration, right? We're at copper right now. Or what we can do is we can fully fill the 3d orbital, and that's actually what ends up happening for copper, is that this electron from 4s will once again jump into this 3d, thus completely filling the 3d and also relieving some electron repulsion in 4s. Okay, so that's going to be the actual configuration for copper, which is again is an anomalous electron configuration. But of course, of these answer choices, the answer is going to be chromium. This is the one that actually has the anomalous configuration of all of these. Okay, so remember those two exceptions.